There are lots of games that simulate drones, but one of the things I've noticed about them is they all give very high quality video output, which is something that you don't see when you're flying a typical FPV racing drone. So I thought I'd create a small simulation of some common camera distortions. So what we have here on the right, we have kind of the input from our 3D scene, and on the left we have the output from the simulated camera. And we have a whole bunch of parameters that we can use to control it. The basics of camera simulation I've taken from OpenCV. So we have the intrinsic parameters and some distortions that are common to cameras. So a radial distortion is your standard pincushion sort of effects, pincushion barrel distortion. And OpenCV, when it works with these, involves what's called R2, R4, and R6. So you can control it at a bunch of different levels. This means you can have it balloon in the middle, but straighten out towards the edges. So here it kind of sharpens into the corners, but it's still very much a barrel distortion. And there's another level of power to control even more there. Tangential distortion stretches the diagonal opposite corners out towards the edges and towards the top. In all of the OpenCV calibration numbers that I've seen, these are nearly always 0. I followed a similar R2, R4, R6 approach for the chromatic aberration and vignetting. So you can insert chromatic aberration and control where it is in the image with a reasonable degree of precision. And the same with vignetting. In fact, it's really obvious with vignetting because you can, you can place it just as a dark toroid in the middle if you really want. You can obviously set the resolution. That's fairly standard. You can also simulate the noise on the pixel on the sensor itself. So there's kind of a static noise. That's the manufacturing tolerance. And there's also a dynamic noise. This is electrical noise from interference on your system. And so it moves and it scrolls, and you can control the speed at which it scrolls. With this you can create a variety of kind of different types of electrical noise. And we've got the gain and the exposure of the sensor. These are roughly the same, but the one takes place before the noise is added. So if I have an exposure of 0.5 and a gain of 2, then I get more noise. If I have an exposure of 2 and a gain of 0.5, then I have less noise. Originally I was hoping to add in motion blur to also be controlled by the exposure, but that isn't possible in Godot. Next we have some sharpness functions. The obvious one is just a standard sharpen effect. The next parameter is a denoiser. And what this means is you can simulate what these cheap cameras do, which is they use low-cost sensors, they blur them and they do all these post-processing and to try and get the best quality image out. And so you can see that lots of the details have been lost, but we've still got these sharp edges around our objects. As I said, this is a fairly standard trick they play, both for resolution upscaling and all this sort of stuff. We've got our standard brightness, controls, contrast. Nothing too unusual there. We've also got a white balance control, so you can tint the whole image to match what you want. I would have liked to do auto white balance because that's very prominent in these drones. When you're pointing down at the grass, everything goes grey. But unfortunately, again, there's issues with Godot, which means that I can't detect this colour automatically. That's about it for the features of this camera simulation. I'm hoping in the future to also try and simulate RF interference from the FPV link, and we'll see how that goes.